So an example of a sequence is like this, 1, 2, 3, 4. It goes up by 1 every time. Now the series would be 1 plus 2 plus 3 plus 4 plus so on. Can someone else give me an example of another sequence? Perfect. 3, 9, 12, and so on. A series would be 3 plus 9 plus 12. All right, I'm going to do a fraction one. Let's do 1/2, 1/4, 1/6, 1/8, and so on. That's my sequence example. If it was a series, it would be 1/2 plus 1/4 plus 1/6 plus 1/8, and so on. Does everyone see the difference between a sequence and a series? Yes. Nice. Okay. So let's go ahead and find a partial sum. A series, we're going to add the numbers in a sequence. Here, we have a partial sum of 7. So a partial sum is notated like this. The sum of in terms. So in this case, we want the summation up to the 7th term. So this is the first term, the second term, third, fourth, fifth. I want to add all of the terms up to 7. So guys, this goes up by how much each time? 4. It goes up by 4. So my common difference is 4. What would the next term be? 22, and the next one? 26. So those are the first 7 terms. So the partial sum would be 2 plus 6 plus 10 plus 14 plus 18 plus 22 plus 26. So guys, go ahead and type this into your calculator. Let me know what this equals. 98? Perfect. So that means the partial sum is 98. We're not going off to infinity. We're just doing partial sums. Just some of them. All right, let's do another example. We want 8 terms. So what is the pattern here? Is this arithmetic or geometric? Let's find a ratio. So -2 divided by 1 is -2. 4 divided by -2 is -2. -8 divided by 4 is -2. So guys, what kind of sequence is this? Geometric. It's geometric. My ratio is -2. This is a geometric series. I'm sorry, sequence. A geometric sequence. Okay, so let's find the next few terms. 16 times -2 is -32. Multiply that by -2, you'll get 64. Multiply this by -2, you'll get -128. So those are 8 terms up there. To find the partial sum, we're going to add those all together. So this will be 1 plus -2 plus 4 plus -8 plus 16 plus -32 plus 64 plus -128. Let me know what that equals. Yes, I heard someone say it. What was it? Yes, -85. So the partial sum is -85. Next example, I want 6 different terms. I want it up to 6. So I'm going to, for my domain, I'm going to plug in 1, 2, 3, 4, 5, 6. These are the numbers I'm going to plug into this rule. Okay? So my first one, we plug in a 1. 1 squared is just 1, so my first term is a square root of 5. We did that one. Next, let's plug in a 2. What's 2 squared? So this will be 4 square roots of 5. Next, let's plug in a 3. We'll get 9 square root of 5. Next, plug in a 4. 4 squared will give you 16 square root of 5. Next, plug in the 5. You'll get 25 square root of 5. And then finally, plug in a 6. 6 squared is 36 square root of 5. Now we'll just add these all together. Let me remind you of a rule. When you have the square root of a plus the square root of a, this is the square root of 2 square root of a. If this was a 4 and this was a 6, this would be 10 square root of a. Okay? So if this part is the same, then you just add the coefficients together. So in this case, we have 1 plus 4 plus 9 plus 16. Add those all together and let me know what you get. You're adding up all of these coefficients. $91. Did y'all forget this one in the front? All right. Okay, so it starts with a 1. The 1. To get the next term, you add these together to get 2. You add these together, you get 3. Add these together, you get 5. Add these, 8. Add these, 13. 21. 34. 55. And I believe this problem just wants the summation up to what? 10. Was that 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So we're just going to add these all together. Guys, this is a famous sequence. It's called the Fibonacci sequence. So let me write that on the board for you. This is the Fibonacci sequence. And you see it a lot in nature. It creates a fractal. It creates a spiral. It's like you see it in shells, you see it in leaves. The Fibonacci sequence. Make sure you research it. It's very interesting. Okay, so the Fibonacci sequence, if you add up the first 10 terms of the Fibonacci sequence, you do 1 plus 1 plus 2 plus 3 plus 5 plus 8, and so on until you add up to 55. What'd you guys get? 143? Perfect. So you add them all up, you'll get 143. So now we're going to represent a series using this Greek letter. This means sum. N equals 1, this means your first term. So your first term is always at the bottom. And your last term is always on the top. And 2n, this is just your rule. This will change. So let's find the sum of this series. So that means my domain, I'm going to start with 1. I'm going to plug in all the numbers between 1 and 5. 5 is the last one we're going to do. We go from 1 through 5. So guys, if I plug in a 1 right here, what do I get? 2 plus, plug in a 2, what do I get? 4. Plug in a 3. 2 times 3 is 6. Plug in a 3. Oh, we just did that, sorry. Plug in a 4. 8. Plug in a 5. What do we get? 2 times 5 is 10. Okay, so if you add these all together, you will get 30. Okay, so now let's look at an example using a summation symbol. So let's do this example here. So guys, looking at this means for my domain, I'm going to plug in first, I'm going to plug in a 3. What number will I plug in next? 4 and 7 and 8. Perfect. These are the numbers I'm going to plug in. That's my domain. Okay, so let's start off with 3. I'm gonna plug in a 3 here. So 3 plus 1 is 4, and 2 times 3 is 6. We can simplify this. It'll be 2/3. Now let's plug in a 4. So 4 plus 1 is 5. Plug in a 4 right here. 2 times 4 is 8. So I get 5/8. That's the next one. Next, we're going to plug in a 5. So 5 plus 1 is 6. 2 times 5 is 10. We're going to simplify by dividing by 2. We'll get 3/5. Next one. Okay, number 6, or we're going to plug in the 6th one. So plug in a 6. 6 plus 1 is 7. Plug in a 6. 2 times 6 is 12. So we get 7/12. Now let's plug in a 7. 7 plus 1, we get 8 in the numerator. Plug in a 7. 2 times 7 is 14. We can simplify this by dividing by 2. So we'll get 4/7. And then our last one, we're going to plug in an 8. So this will be 8 plus 1, which is 9/16. And that cannot be simplified. So guys, go ahead, use your calculator to add up all of these fractions so we can figure out the partial sum. So you got 2,021 over 560. Perfect. That is how you do a summation. Now, guys, one misconception that I saw for previous classes is they thought because they had an 8 right here, they had to have 8 things they added together. That's not the case. It just means you're plugging in numbers 3 through 8. So in this case, when we plugged in numbers 3 through 8, we got only 1, 2, 3, 4, 5, 6 numbers that we added together, not 8. So this number does not represent how many numbers you should have.